Hello everybody, this is Mrs. Shaw, and to start our lesson off today, we're going to fill in this table. Here we have an equation, y equals 3x minus 1. So if our x is going to be negative 2, what will our y be to make this be a true statement? 3 times negative 2 minus 1. Our y will equal 3 times negative 2 is negative 6 minus 1. Y equals negative 7. So for this table, when x is negative 2, our y is negative 7. All right, let's try it for when our x is negative 1. We'll have y equals 3 times negative 1 minus 1. Y equals 3 times negative 1 is negative 3 minus 1, and y is equal to negative 4. So when x is negative 1, our y is negative 4. To save time, we're just going to have the table filled out here for us. And I want us to start recognizing what the patterns are. What are our patterns here? If we look here, coming down this x column, if we look going from negative 2 to negative 1, negative 1 to 0, 0 to 1, 1 to 2, we recognize a pattern, what's happening here. And yes, on that x column, there's adding 1 every time for that pattern. Let's look over here at the y column. What's happening to our y on our y variables? Sometimes it's not as obvious to see what is happening. So I'm going to give you a hint how to tell. Take any number in this column, say 5, and subtract the number above it. So 5 minus the number above it was 2, and 5 minus 2 is 3. Are we adding 3 every time to go from negative 7? Did we add 3 to get to negative 4 and add 3? Yes, we did that every time. So the pattern over here on the y column is adding 3 every time. And as you'll notice, the pattern to get from our x variable to our y variable is we take our x variable and we're multiplying it by 3, and then we are subtracting 1. That was our equation, right? This is what we're talking about in this unit. We are going to talk about how we get an equation from a table if we didn't already know the equation. So what we're going to start off with here is we need to figure out, on an equation, we have our slope-intercept form. We have our slope, y equals, and then we have our slope times x plus our y-intercept. So to start off here, looking at this table, let's figure out what the slope is according to this table. Well, it's going to tell us here that it's the change in y divided by the change in x. So let's figure out, we're going to figure out what our change is. What was happening every time here on the y's? What is happening? What's the pattern? Well, remember, we can take any number in the column, subtract the number above. So 8 minus 4 is 4. Are we adding 4 every time? And if you'll notice, that is our pattern. And so our slope is the change in y. We figured that out, which was 4. And it's going to be divided by, let's figure out what the change in x is. I'm going to switch colors here, and we'll figure out the change in x. Let's do a different color. Okay, the change in x. So let's look over here. What is our change in x? Going from 0 to 3, 3 to 6, 6 to 9, 9 to 12. And we can see that this one we are adding 3 every time. So our slope is the change in y, which was 4, divided by the change in x, which is 3. We can already fill this in to our equation, and our slope is 4 over 3. Our y-intercept is actually really great to see from a table on lots of times, because it is, especially if our table has where x is 0, we know our y-intercept is where it crosses the y-axis, and the point is going to be where x is 0. So the point where it crosses our y-axis is at 0, 4. For our y-intercept, we just take the y value of that. which is 4. So the equation of the line that matches this table is y equals 4/3 x plus 4. Let's do another one. Here we have an equation. We want to write the equation represented by this table. I like to put the y-intercept in here first, especially on a table when we go look. The y-intercept is where x is 0. So what is our y-intercept here? It's -1. Okay, now we need to go through and find the slope. Remember, the slope is change in y. Change in y, that goes on the top, the numerator, is over the change in x. So I actually like to find my change in y first, since that's on the top. So I'm going to come over here, and I'm going to look at my y's, and I'm going to see what is happening every time to go from 1 to -1, -1 to -3, -3 to -5. Oh, well, say I'm not sure. Remember that hint. You can pick any number in this column and subtract the number above it. So here we have -3, and we're going to subtract -1. Remember that when we subtract the negative, that's the same as adding. We're adding the positive. So -3 plus 1 is -2. Are we subtracting 2 every time? You can go through and check here. 1 minus 2, -1 minus 2, -3. Yes, we are subtracting 2 every time. So our change in y, it goes on the numerator for this table, is -2. Now we need to figure out our change in x. Come over here to the x column, and we have -6 to 0, 0 to 6, 6 to 12. We can see that we are adding 6 every time. So our change in x is 6. When we write it as our slope, we have our change in y, -2, over our change in x, which is 6. So -2 over 6. This simplifies down to -1/3. And we write it in the most simplified term. So -1/3, y equals -1/3 x plus -1 or -1 is the equation. This is the equation of the line that is represented by this table. Okay, we're going to move to a level 3 here. And the reason this might be a level 3 is if we're looking, like I like to look for my y-intercept first. And that's where I look to the table and I look where x is 0. And I don't obviously have a 0 right there. Oh, so it's something that maybe I could work backwards. If these are, oh, the change in x looks like we're adding 1 every time. What is happening over here to the change in y? Oh, are we adding 4 every time? Okay, so to find our y-intercept, we could work backwards. And if this was 8, 9, 10, if we're adding 1 every time on the x column, if we're subtracting 1, this would go to 7, and then 6, and we can work our way back. All right? So our y column, if we're adding 4 every time, to work backwards, we would subtract 4, and 3 minus 4 would be -1, and subtract again, we would be at -5. So you can keep working all the way back until you find where x is 0. I'm going to show you another way as well. But first off, since we couldn't find that y-intercept right off, we can go ahead and find the slope. And we've done a lot of the work for ourselves to start with. Remember, the slope is the change in y, remember that goes on the top, 4, over the change in x, which was 1. So our slope is 4 over 1. That simplifies to be 4. Okay? Our y-intercept, we still didn't know. We can work backwards, but I'm going to show you another way as well. Let me clean this up. Another way that we can figure out what the y-intercept is we can pick any number on this, any point on this graph or this table. Let's pick the point where x is 10 and y is 11. And we're going to plug that into this equation here. So our y is 11. We still have our slope of 4, but our x is going to be 10.
And then we're going to add, oh, we don't know our slope, our y-intercept. So that's our question mark. That's our variable. So let's figure out this. Let's simplify it. X equals 4 times 10 is 40 plus, and we don't know. We don't know what our y-intercept is. So let's solve for the y-intercept by subtracting 40 from both sides. 11 minus 40 is negative 29. That equals our question mark. Oh, let's see. Did we figure out what our y-intercept was? This was our question mark. Let's plug in our negative 29. Whoops. How do we know? How do we check to make sure that's right? All right, I'm going to clean this up a bit so we can check here. And we will go through and check. So, let's see here. We're going to pick, let's pick a different point, not the one that we used, but let's pick another one. Let's try 8 and 3. We're going to plug that in over here and see if this makes a true statement. So our y, we've picked the point where y is 3. Is that going to equal 4 times, let's see, our x, we said was 8 plus negative 29. Let's see if this works, if this makes a true statement. 3 equals 4 times 8 is 32 plus negative 29 is 3 equal to, let's see, 32 minus 29 is 3. That checked. That was a true statement. So here is our equation of our line from this table. Let's see here. Okay, another part of the assignment will be changing equations that are in slope-intercept form. That's what we've been practicing writing them into slope-intercept form. We're going to rewrite them into standard form. And this is a process that you'll do even as you go on in math, is switching from slope-intercept form to standard form or back and forth. So we're going to practice one of these. Actually, the slope-intercept form, remember the m was your slope, the b was the y-intercept. And these are just numbers. The x and the y are our variables. The same with standard form. This a, this b, and this c, these are just numbers. So it's the coefficient. It's the number in front of our x, the number in front of our y, and then c is the constant number. One thing about the standard form is they usually are not written with any fractions. So if our equation here, which is already in slope-intercept form, we have our y equals, our slope is 1/2, and our y-intercept is 7. We need to rewrite this in a standard form as an equation. We're going to write an equal equation in standard form. Usually does not have any fractions with it. So we're going to go ahead and just start off by doing the fraction trick. Okay, here we're going to protect our denominator. This is our circle, our denominator. That's our balloon. Remember, it's going to explode and it's going to hit every other term in the equation. 2 times y is 2y. When it explodes, it multiplies everything else by what's on the denominator here. The 1 was protected, and then 7 times 2 is 14. So we've gotten rid of the fraction. That's part of getting to our standard form. But you'll notice our standard form here, we have our x term first, and then our y term, and then it equals our constant number at the end. Here we have our x term is on the opposite side of the equal sign. So we want to get it over to the other side. So we're going to subtract to the opposite of adding 1x, we're going to subtract 1x. Remember, x and y are not like terms, so I'm going to write it separate so we can tell that we can't combine them. So here we have another way we could have written this. Maybe this will help to be less confusing or more confusing. We will see. If we subtract x, maybe some people are like, oops, that didn't work. Sorry about that. That was 2y equals, okay. We're subtracting x from both sides. Sometimes you can just write it as 2y minus x, okay? That equals this x minus x goes to 0, we have 14. This is not quite standard form yet because we need our x variable first. Remember that we can, when you have this negative, this subtraction is the same as adding a negative. And when we're adding here, we can rewrite the order, put the x term first, then our y term, and that is going to equal our constant. Okay? So we have our ax, it's in the form of ax plus by equals 14, where our a right here is going to be 1. We don't need to write the 1. Our b is 2, and our constant number is 14. All right, I hope that helps, and have a great day.